Great. So welcome. Thanks for coming out to hear about some of the new infrastructure solutions that Marvell is developing and innovating to really optimize the modern data center. As we know, there's lots of innovations ongoing right now, given the dynamics and the new era of the data era. So we'll start to go into the details of what's driving some of the changes in the marketplace to drive new data center architectures. And then we'll go into some of the solutions that Marvell is bringing to market. So if you look at what's been going on over the last 40 years, there's been waves of innovation. And these waves of innovation have driven productivity growth. So not just new technologies, but you've also had our standard of living and the outputs coming from businesses continually increasing. So if you look at my lifetime over the last 40 years or so, there's been, I would say, at least 4 waves of innovation. Starting in 1983, the advent of the PC was the real first wave of innovation that I experienced, and that really drove some of the productivity gains of moving from typewriters, from manual type of ledgers to spreadsheets and computational on a system from a personal computing perspective, starting with just basic text, Word type of activities. That was an era that went on for about a decade, and then we ran into the second wave, which was the internet revolution. And this revolution and wave really drove significant productivity gains. It really made the world flat, right? So we were able now to do stuff not only locally, but also now remotely across the globe. And we saw significant new businesses come up on board, right? You saw companies like Google, eBay, that all came shaped from this wave and really changed the way things are done from productivity across the world. Now, the second wave really took off when you combine it with the third wave, where the third wave was the mobile era. So if you look at 2006, 2007, that was when the iPhone came out. Now, that iPhone, if you remember correctly, really changed how we did activities with the applications, with the apps. That drove another wave of productivity, right? It really built upon the second wave where now you were mobile and you were able to do stuff on a device. This was significant, and I still remember before this, I was using my BlackBerry and all I could do was little emails, but I couldn't really do anything significant from an application perspective. But the iPhone changed that dynamic. And really, it wasn't just the iPhone, but it was the introduction of the App Store on that system. And then the Android came and it just took off. And we're still living off that wave. But that wave, if you combine it with the cloud era or the cloud wave, this is where not only were you able to get a higher productivity from an individual perspective, but now from an actual enterprise perspective, if I was going to start a company tomorrow, I don't have to build my own data center or buy my own gear. I can now just go out to the cloud and rent compute cycles and infrastructure to get my company up and running and scale as the company grows and addresses certain waves of upsides and downsides, really fine-tuning. And this era or this wave is still ongoing, right? We're just, I would say, in maybe the 5th inning, 4th inning of the ball game of this era. And this era is actually going to drive the next wave that we just started over the last year, which is the data era. Now, the data era is where companies and individuals like ourselves are actually extracting value out of the data created. Now, this data is not only created by individuals like you and I, it's also created from machine to machine. Now, machine to machine is actually where you're going to see this plethora of data that skyrockets and it's going to drive new infrastructure requirements, not only in the cloud, but at the edge and at the end user side of things. IoT is one of the areas that plays into this 5th era or 5th wave. And I believe this is where you're going to see skyrocketing data creation and the opportunity to create new solutions that take advantage of all that data created. These two last waves are really where you have software-defined infrastructure. And what we're going to talk about today is not only the software-defined infrastructure, but the ability to compose infrastructure based on the requirement for that specific use case. And I think this is really a key thing that's ongoing right now is the rush to actually innovate with a composable piece of infrastructure. And this, we'll show you the details here, but it doesn't have to be a complete data center. It could be actually just an IoT component that actually has compute, storage, all built into it to actually do analysis at the endpoint versus bringing it into the cloud. And that's one of the big activities right now with AI, 5G that Marvell's working on with the industry to really drive as you move to these more intelligent endpoints. Now, the data era is driving the need to transform the infrastructure. You have unprecedented demand, growth, and velocity. So what I mean by velocity, it's happening so quickly that you don't have significant time to really plan for it, and you got to have infrastructure that can actually transform and adapt in a real-time manner. And that's where this composable infrastructure enables you to do that versus trying to combine everything into that infrastructure, which is not optimized for a given use case or workload. The other requirement, as I highlighted, as more and more data is created at the endpoints or at the edge, latency and the amount of data being created drives the need to do the computational analysis at the edge points. And that's a key point here is that you're not going to be able to move all the data back and forth from the endpoint to the cloud, just because there's going to be too much data and you want it to happen in a real-time manner. So the latency factor is significant, and this is where really 5G plays a big factor along with some of the machine learning and artificial intelligence that will decentralize the cloud. And that's why you have lots of analysts out there stating that the next opportunity is edge computing, which will be significantly bigger than cloud because you'll have more and more of these endpoints where you're going to be doing computations and analysis on at the endpoints. What does this mean? This means you're going to need optimized architecture solutions to address that. So compute, controllers for storage, networking, offloads, accelerators, and this is where you're seeing more and more startups, more and more investment happening in these areas to really drive optimal solutions going forward. And as I highlighted earlier, 5G and artificial intelligence will accelerate these disruptions because now you'll have bigger bandwidths coming in from the endpoints to enable data to move between points. That's the other thing. Machine to machine is 5G is a key driver of that because now you have faster bandwidths. A car can talk to the other car to avoid crashing in an autonomous type of environment, right? 5G is going to be a key driver of that, and then AI builds on top of that because the AI is going to be analyzing, the data coming from that car to see, hey, am I close? Do I slow down? Do I speed up? So on. So these two together combined will drive significant disruption. Now, the key point here is one-size-fits-all data centers will no longer work because of all these moving parts. And that's what we're going to talk about today. So today's modern data centers, as I mentioned, are migrating to composable infrastructure. So you have compute elements, you got networking elements. Now, networking elements is two pieces. You got the fabric, and then you got the networking interface coming out of these elements. So there's two pieces here. Today, I'm going to touch more on the fabric versus the network interface cards, but they go hand in hand, and that's where these interconnects come into play to really make this composable infrastructure a real thing. Then you got NVMe storage class memory. You got NVMe storage, both SATA and SSD storage. You got your HDDs, as the gentleman earlier from Seagate was highlighting. There's lots of data being created. You're not going to put it all on expensive flash storage, even as the costs come down, there's still a big delta between flash storage and HDD storage. So you're going to have homes for both medias. And then you have accelerators. So you have GPU accelerators, which NVIDIA is leading the pack on. But then you have what's happening now is more and more application-specific accelerators. As you understand these workloads more effectively, you're going to build dedicated accelerators to optimize your power, cost, and complete TCO. So going forward, what's going to be critical, and this is where the open compute community comes into play, is architecture solutions that support open standards are critical to drive innovation. It's critical that these standards are open versus closed to really drive adoption and get the best economies of scale going forward. So what I'd like to introduce today that we announced earlier this week is the composable data center switch fabric called the Marvell Pressera CX8500 family. This product family has been around for 20 years, the core technology, and Marvell shipped more than 3 billion ports. This technology, what we've done over the last 3 years of development, is really now enhanced it for more scalability and more, I would call it, lower latency and more granularity visibility into the actual data flowing through these switches. And we'll talk about this a little bit more. The other key thing here is Marvell's also leveraged our mixed signal expertise to build a solution that supports both 25 gigabits per second physical layers as well as 50 gigabits per second physical layers. So this enables you to scale going forward in different architectures, because some architectures will have 25 gigabits per second physical layers, while others will have 50. As you scale up, you want to reduce the number of optical links, you'll move to 50 gigabits per second. So our architecture here that we rolled out supports both. So it really gives the data center makers and operators the ability to compose the right piece of switch for that given infrastructure. The other key thing that I'll talk in the next 2 slides is it integrates some new innovations that our switching team developed, what we call safe and faster technology, which enables you to even have more optimizations for this composable infrastructure. So if I just start to deep dive a little bit on these innovations, so SAFE, which stands for Storage Aware Flow Engine, enables you to track flows real time to give you network resource visibility. So it makes you it gives you the ability to see what's happening. Is one endpoint sucking all the bandwidth? Is there a rogue device that's actually stealing all the data and starving the other ports? It gives you the ability to do this real time with hardware accelerators that our team put in there. It pinpoints, is a drive actually congested? Is there someone out there that's rogue that's actually aggressively stealing all the bandwidth to bring down a node? So this device, or these devices, can limit the bandwidth of a given host and move the data from a congested disk to another. And this is very key as we talk about composable infrastructure. We're building an architecture here that's composable not only for networking, but for storage, GPUs, and accelerators. And here I'm using the storage because in a few slides I'll show you what we're doing on storage around this composable infrastructure. Faster technology that the Pressera family enables really reduces power consumption and latency. It enables you to really cut the number of network layers, as shown in a legacy network, down from 4 to 2. So this really cuts your power, your cost, your latency, and overall performance. And depending on the actual setup, you can get network costs down by greater than 50%. And this, again, is really enabled by the core switch IP we have inside our switch family that enables you to scale up to multiple high-performance modular nodes to 1,000 ports. And this is significant value going forward. We have a reference design that we're demonstrating downstairs in our booth where we show this this solution in action. So I really encourage you to go check it out. It's not only in action as a standalone, but it's also in action in this composable rack that we'll talk about in a few slides. The other piece of this composable infrastructure that Marvell is enabling or providing to folks is the NIC side. I told you I'm not going to talk in detail about the NICs, but we do have a complete product family of NICs that enable you to take all these different pieces, connect to our fabric, and enable this composable infrastructure. So we have families ranging from 10 gigabits per second all the way to 100 gigabit Ethernet accelerator type of solutions. And these support multiple protocols because, again, we want to make it composable. Everyone has different requirements for their infrastructure. Some are using iSCSI, some are using RDMA, some are TCP/IP. So we have integrated offloads and accelerators integrated into these NICs. And the key one I want to focus on is the NVMe over Fabric, because that's a key one as I talk later about our end-to-end NVMe over Fabric storage solution going to the drive level. So we put actual accelerators and offloads for both RDMA over Rocky, as well as RDMA over TCP/IP. So that's a key thing going forward. And these are available in OCP 2.0 and 3.0 form factors. So again, we've already worked with the community to get these drives out and continue to enhance going forward. Next area that I wanted to talk about was the actual ARM server processor side. So we have the industry's leading ARM server CPU class for servers. And these solutions that were introduced over the last 18 months actually bring significant cost savings, not only from a die size perspective, but from a total TCO, given some of the integration we've done here from the actual enhancements on the cores to the actual number of integrated accelerators inside the server CPUs. And we've shown, depending again on the workload and use case, up to 4x TCO savings against competing x86 solutions. Here you can see how we benchmark against some of the Xeon class of solutions from a throughput perspective, latency, network flexibility, meaning like the PCIe lanes, and then the complete performance perspective. Here too, we've been working with the OCP community and have done a project Olympus with Thunder X2. So this is available. Again, enables you to now build a compute engine around ARM. So that's something significant that customers and data center users can now leverage going forward. You're not only privy or limited to Xeon class of processors, you can use ARM for specific workloads where we shine, as shown in the different slide, was the memory throughputs, some of the I/O connectivity. This will enable you to do that. All right, so let's get to the area that I get most excited, because I'm a storage guy, is the area of today's composable SSD storage has significant challenges. If you look at today, you're going through a NIC and a CPU complex to get your composable JBOF. This has latency, power, and has significant bottleneck around oversubscription. And that is a key thing that I want to highlight here. This is today's composable storage node for SSDs, but you can see that you're oversubscribing the network link there because each of those drives can give you 25 gigabits per second of performance. So if you have a 100 gig NIC, 4 of those drives becomes the bottleneck, right? So how significant is this bottleneck? As I highlighted, one drive can give you about 32 gigabits per second. As you scale up to PCI Gen 4, it's 64 gigabits per second. And then as you go to PCI Gen 5, it's 128 gigabits per second. So if you put 24 of those in a 2U enclosure, you need 768 gigabits per second NIC coming out, which we all know is not around the corner and is not going to be very cost friendly. And it just gets worse as you scale up. Now, the pipe's not the only issue. The other issue is you have the CPU in the middle, you have DRAM, and you have power and latency issues around this, right? So your TCO really gets bent out of shape when you try to scale this out and get the performance out of those drives. So what is really needed here is a new high-performance, low-latency, scalable architecture. And this is where Marvell introduced at FMS last year a new composable SSD storage solution. And this is really taking Ethernet to the drive level. And this enables you to go end-to-end NVMe over fabric in a simple scalar, in a linear scalar manner to get native performance out. And this optimizes the dollar per IOPS and the IOPS per gigabyte. So 24 of these drives in an enclosure can give you 16 million IOPS. While before you're limited by that NIC, you'd be lucky if you get a couple of million IOPS, right? So this shows you with our Pressera switches combined with our storage innovations at the NVMe or Fabric converter controllers that you're able to now get linear performance out. And this is something that'll drive new architectures going forward when you look into this new data era that we're starting to build the infrastructure. So we announced this at FMS in August, and now we're in the early development phase with multiple OEMs and cloud data centers building these solutions. And if you had to compare the two solutions together, as I highlighted, you have limited performance with today's composable storage node, high CPU power, and high bill of materials, while the other one scales linearly. So you save significant from a TCO perspective. With our partners Toshiba, we showed greater than 65% TCO savings, excluding the SSDs, because the SSDs are going to be equivalent in both. But in the second architecture, you're getting significantly more performance. So the value is translated to the end customer to get that performance out of it. And then one other one I wanted to compare to is if you look at today's OCP project, Olympus FX16, you're using a PCI fabric where the storage node and the JBOF are connected directly, so it's a 1-to-1 ratio. If you move to the EBOF architecture, now you can actually split the two, and you have now storage shared, the EBOF shared across multiple storage nodes, and you're able to lower your rack costs because you're now able to fit more storage in there and take up less space, less power, 30% less power, and 50% more rack capacity. So this eliminates the 1-to-1 storage node to JBOF ratio and gives you more efficiencies and utilizations. Very critical as data centers scale out. And last but not least, I said HDDs are not going away. So what are we also rolling out is we're rolling a solution that we call Ethernet bunch of disk. Just like we had Ethernet bunch of flash on the previous one. This is an Ethernet bunch of disk where you can have the same architecture to leverage common management and fabric for HDDs, SSDs, and SCM. It supports SAS, SATA, and NVMe HDDs, as the Seagate gentleman mentioned earlier. Those are the main HDD interfaces with offload capabilities. It eliminates the need for CPUs, smart NICs, SAS controllers, and expanders, again, taking all that cost out. And it really minimizes your TCO with best-in-class power. And this, again, is being demonstrated in our booth. And this is exactly what's being demonstrated in our booth. So you can see a picture of the actual rack. Here we have the Pressera switch fabric at the top. We got compute nodes in those blue boxes there with the Thunder X2. We got our NICs with our FastLink, and then you got our EBOF and EBOD. So this is all live, real stuff that you can touch and see running traffic in our booth. So I encourage you all to go check it out. So to bring us home here and summarize, the data era is upon us and morphing data center architectures. One size fits all does not work anymore for data center. You really need composable infrastructure going forward to really address these different moving parts, what you want to address going forward. Because every workload's a little different. You don't want to use one piece across the board. Marvell is offering multiple open chipset solutions to address this infrastructure. I showed the networking, you saw the compute, you saw the storage. You could put these pieces together and really have an end-to-end solution from Marvell, and we're willing to be very open with it and contribute to the community. So from a call to action perspective, we would like to continue developing OCP reference designs around EBOF and EBOD. So that's something we're taking on, and we'll be working over the next quarter to a couple of quarters to get the ecosystem around that with our switches and our storage devices, because you have new management, new infrastructure requirements. We're going to develop specifications for the OCP community around this composable data center fabric. We will want help to standardize the Ethernet SSD connector, because that's critical going forward. And then to wrap up, we encourage you to attend tomorrow's Ethernet session that one of my colleagues is going to be doing. So thank you very much.